Well, hello everybody. I am going to tell you about EDNS Client-Subnet, that's ECS for short. I've entitled this Getting Started, and this is based on the KB article of the same name, but I'm going to go into a little bit more detail than just getting started. So this, I hope, will be useful to people who have no idea what ECS is, or have some idea but have not really started looking at how to make it work. But also there may be some nuggets in here for people who have already started playing with it or configuring it and are not sure about some of the additional options that they could use. So I'm going to cover what it is, why you might want to use it, give you a very simple first configuration to try, and then get into a little bit more sophistication, looking at prefixes and scopes. That's where you identify how much information about the client should go to or should go from a resolver to authoritative servers. And then I'm going to cover things like forwarding, because the basic idea that a client asks a question of a resolver, which then goes and asks the authoritative server, is not the entirety of all configurations. And it may be that you have several layers of servers querying other servers that you need to take into account when configuring ECS. A little bit about how the cache works, and then I'm going to cover some of the pitfalls that you can encounter if you do choose to use ECS. So why? In a very simple world, clients are close to their DNS server, and their DNS server asks questions on their behalf of authoritative servers around the internet. The authoritative servers these days, though, have started doing geo-specific type of replies. So if the query comes from or appears to come from a client in, say, France, then they may well direct the answer to be sending the client, when they're going to their website or whatever, they will go to services that are specific to their geolocation. This is fine, but the world has moved on, and quite often these days, the DNS server location IP address doesn't represent the clients or doesn't represent all of the clients that will be using it as their resolver. So how do we get around this problem? So wouldn't it be really nice if a resolver could look at where the client query had come from, because the resolver does know this, and then could indicate to the authoritative servers that it is querying on behalf of its clients where the clients are. By the way, observe these flags, because at the end of this presentation, there will be a little quiz to see if you recognize the flags that I've used in the presentation. Just a little bit of fun. So moving on, so what if the DNS resolver could ask questions of an authoritative server, indicating to that server where its client asking the question is located, and then it could pass the answers back from the authoritative server to the right clients. And in this example, we have two clients in two different locations, each getting different specific answers from the same resolver. So that is what EDNS Client-Subnet, ECS, is all about. An ECS-enabled resolver has the ability to indicate to the authoritative server where its clients are located, or where the client asking this specific question is located. And it does this by indicating that via subnet, but masked. So it's not the entire client IP address that it is passing on. And then when it receives a reply from the authoritative server, it can cache it, and it can use it for other clients in the same subnet But if it gets asked the same question by a client from somewhere else, then it will ask again of the authoritative server, get a different answer with a different scope, and it will cache that as well in case it is asked again by another client from the same different scope. This is all covered in this RFC 7871, which I recommend thoroughly as good reading, because if you are reasonably au fait with the DNS protocol, it covers a lot of what ifs and niche scenarios around ECS that are useful to understand. So, having heard that it exists, let's try it. So here, I have looked up my local IP address for google.com, and I have sent it a query. I'm actually pretending here to be a resolver. You can tell I'm pretending to be a resolver because I have turned off recursion, that is plus no rec. I've used plus QR because I want to see the query I send as well as the response I get back. So I have queried google.com's name server, and I've actually asked for google.com, but I have said that my subnet is 82.71.29 with a mask of 24. So I would like to receive, if possible, a scoped response from the google.com name server that is applicable to my subnet. So if you have a look at the query that's been sent, you will see that ECS, or client subnet, is one of the additional extended DNS options. If you look down about 2/3 of the slide, you see that the client subnet option is indeed 82.71.29.0 with a mask of 24. That's the source scope. The following 0 is what we hope that the authoritative server will complete when it sends its reply. And oh look, I've also sent a cookie, but that's by the point. And the question that I've asked is, please can I have the address for google.com? And what I have got back is minus a cookie. So obviously google.com are not supporting cookies. But I do have in my answer, the client subnet has come back. You can see that I asked with scope 24, but the answer I've got back is applicable to a subnet mask with only 18 bits. So it's more general than the answer than the question I asked. So I know that this answer is applicable to a wider scope than the particular one that I've asked, and I will cache it. We can also do exactly the same thing using V6. So this time I've made the same query and to the same server, but this time I've asked for a different subnet, this time using the V6 format. And I have got an answer back, which is completely different from the one I got before. And again, the Google server has echoed back the question of the client subnet that I asked, which was with a scope of 56. And again, it said, actually, I'm going to be less specific than that, and I'm going to give you a mask of 48. And this time, to my complete surprise, I had never expected that. I've been given a set of 6 answers. So I have no idea what the provisioning is, but this is the way that they've decided to do that. So that's how you make it work. So very, very cute, very, very nice, but I have to give you some warnings. So firstly, although there is an RFC for it, it is not a standard. It is documentation of something that is in use, but it hasn't been standardized yet because there is a lot of concern about the privacy implications, because you are passing information about where clients are located to authoritative servers that you know nothing about. DNSSEC validation may or may not work. There's a little bit about that in the RFC and a little bit about that in the implementation about which record types are covered and included in ECS type queries. So it might work, it should work, maybe. It's a cost benefit thing as well, because once you enable ECS in your bind resolver, instead of having one answer for each query you make, you could have several. In fact, you could have quite a lot. So you could significantly inflate the amount of space you need for your cache once you've enabled ECS. And actually, if you're trying to enable it globally, be aware that not all authoritative servers will actually respond sensibly or even at all if you query them using ECS. So swings and roundabouts. Bear in mind that if you want to implement this, that you're going to have to work around several things depending on your use case. ECS is not available in open source bind. It's only available as a feature in the S edition. Also be aware that bind provides a resolver solution for ECS, but we don't have an authoritative implementation. Right, so getting started. I'm going to mention this because I'm going to mention a gotcha later on. So the Bind 9 S edition, as unpacked from the box, doesn't automatically do any ECS at all. It will behave in exactly the same way as open source bind did. So as long as you don't configure any ECS options, you can expect it to behave exactly the same way as the open source edition with respect to EDNS Client-Subnet. Right, so you decided that you're going to use ECS. How do you make it work? The simplest configuration of all is using just one option, and that is ECS zones. And what you do with this option is you tell your resolver which domains you want to send ECS options to when you are querying their servers. And you can actually do a little bit more than that. You can also do a negation. So you can say, I want to send to these zones, except I don't want to send ECS for these names or these subdomains of these zones. So you've got exceptions as well as please do. So here are some examples. The first example is if you were fairly rashly going to enable ECS for everything that you handle from your clients. And here I said ECS zones and dot. So that is the root and everything below root. I'm saying I want to send ECS on my queries. Or you can say, right, I'm going to enable ECS, but I only have a specific set of zones for which I want to enable it, and I'm going to list them. And here I've listed example.com and example.net. You might do this if you were using it for some internal domains for your own purposes, for example, but didn't want to use ECS outside of your organization. And I did say that you could do exceptions. So I'm giving you an example here. And I have said I want to send ECS to example.com and example.net, but I don't want to send any queries for any names that end with excluded.example.com or end with excluded.example.net. So that's how you do exclusion. However, and there is something that can bite you unexpectedly when you are configuring ECS zones. So what you are saying with ECS zones is, if I am sending a query to one of the name servers for this zone that I have listed in my ECS zones options, then I want to use ECS with those queries and also below those zones. But it's not saying if the name queried by the client matches ECS zones, then apply ECS or add ECS options to the query. Now that's quite subtle, so I'm going to give you an example. Guess, I like cats. So as a client, I'm querying for fluffy.cats.example.com. And because I like cats and I want to use ECS because I want cat pages local to me, I've said ECS zones cats.example.com. Great. So in the process of resolving cats.example.com, my resolver happens to send that query. Well, it sent it first to probably the com servers. It might have sent it to the root servers first, and it would have been told where the com servers were. And then it will send the query to com, and com will say, well, I don't know, but here are the servers for example.com. And then in this worked example, I send the query of fluffy.cats.example.com to the servers for example.com. And these servers actually are authoritative for both example.com and cats.example.com. So I get the answer back right away. But I don't have example.com in my ECS zones, so I did not use any ECS on that, even though that's what I wanted to do. So this is where I'm trying to explain that whether or not to use ECS is based on the name servers and the zone for which they are authoritative being compared with the ECS zones configuration. I hope that makes sense. If it doesn't, please do ask afterwards.
Kathy, is that because the answer was already in cache?
No, it was because the server for example.com is also authoritative for cats.example.com. So as I was working to find the server to query, I sent my query to the servers that I knew that the NS records that I had were for example.com, and example.com is not included in ECS zones. So I didn't add ECS to that. And I never got anywhere near querying any servers for cats.example.com because I got the answer directly from example.com.
So it's because of the configuration on the authoritative side that it was authoritative for both?
Yes. Whereas I had said on my resolver side, I only want to use ECS for cats.example.com and below. And okay, I queried for fluffy.cats.example.com, but my query was being sent at that time to the name servers for example.com, and they are not included in my ECS zones. And I didn't need to send any more queries. However, the exclusions are actually handled differently. So send to these zones, it applies to the name servers that you're, or the authority of the name servers that you're querying. But the don't send ECS is a match against the query name itself. And I've given you another example below, so let me move on. So this time I've decided I'm going to query for spotty.cats.example.com. I have a spotty cat at home as it happens. And I haven't fixed it. I said that I had, and I haven't. So this slide is wrong. What it should say is ECS zones cats.example.com, because I worked out from last time that I needed to be more, no, I have fixed it. Sorry, I lied. I have changed my ECS zones to be example.com because I know that the example.com servers are also answering for cats.example.com. So I have fixed it. And so my resolver sends the query to example.com. Great, we match the ECS zones, and so we should add ECS. But I've said I don't want to use ECS for spotty.cats.example.com. And the resolver won't use ECS for this query because it is matching the exclusion to the query name. So that's different. This is all actually explained in the S Edition Administrator Reference Manual, but I thought I would call it up because it has caught some people out. So I thought it'd be useful to emphasize it. Moving on. So I've shown you how to use ECS zones, and that's your basic configuration for enabling ECS. But there are other options around. So I gave you at first a very, very simple example, which was client queries resolver queries authoritative server. But again, life is not like that. Quite often you have cascading series of local resolver queries another resolver, which might query yet another resolver, which then queries the internet. So there is an ECS forward option to help with that. There is an ignore ECS option. So you remember I said that the S Edition out of the box without any ECS configuration knows nothing about ECS and behaves just like open source bind. But as soon as you have started to configure ECS, it then does one or two things slightly differently. And one of the things it does slightly differently is if it unexpectedly, without having queried and expected to get a reply back with ECS options in it, gets a surprise set of ECS options in a query response from a server, then it will just dump them and say, I didn't ask for ECS, this is badly formatted, I'm not going to use it. So suddenly you've introduced a difference in behavior between your S Edition with ECS configuration and standard open source bind. There's another sophisticated option, which is ECS types, which you might use, although to be honest, I haven't seen a use case for this, but you can use it so that you only use ECS on certain record types, certain types of query. So ECS forward. This is the simplest example I can think of for a two-tiered setup. So like the example before, I've got two clients in different locations querying a DNS resolver in a third location, who is then sending queries to the authoritative servers on the internet. Only this time, my apparent client, client 2, isn't actually a client at all. It's another DNS resolver. And its queries have come from more clients who are somewhere completely different yet again. So ECS forward is to enable the resolver to use ECS as passed to it by another resolver and use that ECS information when it's sending the queries to the authoritative server, instead of saying, oh, these are for the subnet of client 2 where that's located. Actually, we're ignoring where client 2 is, and we're taking the information that client 2 sent to us about its actual clients 3 and 4 and using that instead of what we know about client 2's location. And then this is the replies coming back. I've still got client 1 that isn't sending any ECS of its own, and so we used its location when we queried authoritative. But in the case of the queries that come from client 2 put ECS options on the queries it sent to us, the DNS resolver. So we honored those and we sent those options to the authoritative server and got answers back that were applicable to those and sent them back to client 2. And client 2 will be doing the same game as the resolver is doing, as the DNS resolver is doing when it's responding to clients 3 and 4. So that's how you do cascading resolvers with forwarding. Use the ECS forward option. And this is it in action. So what you do with ECS forward is you say to your resolver, who you will accept ECS tagged queries from, and then use those instead of the ones that you might put on yourself. So it's in addition to ECS zones. Note that it only applies to ECS zones. So a client could send ECS options for something completely different, not within ECS zones, but that isn't going to work. It doesn't override ECS zones. You still have to say, as a resolver, which zones you're going to do ECS for. And I'm going to cover ECS bits and scope a little bit later on, because there are some provisos with that, because a client might be try and be more specific or less specific than your resolver is configured to do. I'm going to mention at this point because it's useful to know. So we have said all the way through, okay, so my resolver is now configured to reveal the client subnet to the authoritative server on its behalf. But the client can actually disable that itself. So if it puts its own prefix 0, that means global scope, no subnet information provided at all. If it puts that on the query it makes, and any client can do this, there are no rules about that. Any client can say, I do not want you to do ECS on my behalf. Then the resolver will not put ECS on the query to the authoritative server. Or it may ask with global scope if the outcome is the same. However, there is now a gotcha. If once you have started to do ECS on your server, and if you have no ECS forward configured, that means that you are not allowing any clients to put their own ECS options on the queries that they send to you. So you're saying, I'm doing ECS, I'm responsible for it. If you put ECS on your queries if you put ECS options on your queries to me, actually, I'm not going to accept them. I'm going to respond with refused. So have a think about that one when you are enabling ECS in your resolver configurations. The one exception to that is the one on the point above, which is that any client, irrespective of whether they're in ECS forward or not, can say, don't do ECS for me. So this is why that last bullet point says client queries containing non-global ECS options will be refused. And I have an example of how to do it. So the ECS forward syntax is just a list of addresses and subnets for which you will accept EDNS Client-Subnet in the client query and then use it if applicable. And like all ACLs, you can do quite complex constructions of this but not this, and these but not the others. So this can be as simple or as complicated as you need it to be. I touched on this one before. This is where you're not expecting to do ECS for a particular zone, but suddenly out of the blue, the resolver that you have sent a query to without any ECS options on has responded with ECS in the response. Oops. So if you had not been configured to do ECS, then that wouldn't be a problem. But now that you are configured to do ECS, you're going to reject by default any unsolicited query responses from auth servers that have ECS options in them, unless you set this option to yes. And then that gets around the problem of surprise authoritative servers. And yes, there are plenty of surprise authoritative servers out there. So this is a workaround. And I did touch on this as well. I mentioned it in passing. You ordinarily, when you are adding ECS options or when the resolver is adding ECS options for a query that it's sending to authoritative servers, it will add it for all record types that it makes sense to add them for. Similarly, it will accept the responses for record types that it makes sense for it to do so. There are some that it doesn't. Infrastructure, delegation type replies, NS and SOA, you'd expect those to be more universal. And also some of the DNSSEC types. This is again so that DNSSEC validation hopefully will work. But you can override that if you want to. I could not think of a use case for that, but it's there if you need it. But also, CNAME is special. CNAME is always special. The thing about CNAME is it represents a, you asked for this query, but instead please go and make this query for this other name instead. And so you have to treat that as special when you're doing ECS as well. So it doesn't really matter. You wouldn't add it to ECS types if it's not listed in ECS types. We're still going to do ECS for it if the source query from the client was a type that was included and we got a CNAME back. Well, yeah, we're still going to do ECS following that CNAME chain because that's how CNAME works. We've gone through the whole of this so far without even thinking very much about privacy, other than me mentioning it right at the beginning and saying, well, we don't actually spill the beans on what the client IP address is. We use a subnet. So we can tune this a little bit further. You can restrict how much information you give about the client IP address, the client IP subnet, by using a global option ECS bits, but you can also do a little bit more than that. You can make it more specific or less specific on a per zone basis as well. There's another option, ECS privacy, that you might use, typically if you're in a forwarding environment, I think. And you've also got the ability to add exceptions because, you know, authoritative servers do unexpected things. And if you know that you have some servers that you really mustn't send ECS options to because they will do bizarre things in their replies or just not respond, well, then you can turn it off in the same way as you can turn off various other EDNS options on a specific server basis. Sad, but unfortunately, sometimes you have to do things. And yes, it is kind of whack-a-mole type. You're going to have to keep updating this as you find exceptions that you need to add exceptions for. So ECS bits. You saw in the example right at the very beginning when I was using dig, and you know that the client is querying the DNS resolver from its own IP address. And then you saw in the example as well that when the resolver is sending the query to the authoritative server, it isn't sending the client's absolute IP address. It's actually sending the client's subnet. ECS bits is the configuration for where the subnet mask is applied. So the scope, the amount of information that you want to reveal about your clients when you're querying authoritative servers. So the default is 24. That's the first 3 octets for IPv4 and 56 for IPv6. They are also the maximum allowed. So what we've done, we've built bind with the default of 24 for v4 and 56 for v6 to help you not accidentally shoot yourselves in the foot. We've made them the maximum. You can't go more specific than those unless you build bind a special way to allow you to override them. Note that changing the maximum doesn't change the default. And note also that if you're using packaged versions of bind S edition rather than building it yourself, we have actually increased the scope to 64 for v6. But if you want to go beyond that and be more specific, sorry, you're going to have to build it yourself. Oh, and by the way, if you do change the maximum when you're building it, it doesn't change the default. You're still going to have to configure. And we have some examples. The first one shows you a configuration where somebody has said, well, actually, I'd quite like to know what the defaults are, and I'd like them in my config so I remember. So we've got 24 bits for v4 and 56 bits for v6. Then we have an example where somebody wants to be just a little bit more cagey about their clients and have set 16 and 48. And then finally, we've got the maximum set. So this ECS bits of 32 and 128 is revealing everything to the server, the authoritative servers that it's querying. Why would you use that? I have seen it in use, but I've seen it in use for one zone that was specific and internal to the organization, and ECS wasn't enabled for anything else. So yes, you've got no client privacy for internal servers or internal zones, but you're not using ECS for anything else. You do that with ECS zones along with ECS bits. And you don't even have to leave it there. You can use a global setting, but you can also use different settings per zone that you specify in ECS zones. There are some catches. Imagine your DNS hierarchy getting more and more specific. If you started off and said, okay, the defaults are 24 and 56, but I don't want example.com to have ECS options with a bigger mask than or bigger scope than 20, that's fine. But then you can't then put my.example.com back at 24. That's not allowed because you've already limited example.com to 20, and you can only go less specific, not more specific. And here we have an example of using bits v4 and bits v6. I'll just give you a moment to look at that one. That's actually quite a complex example because we've used ECS zones both with example.com being enabled for ECS, but restricted to 20, a subnet mask of 20 for v4. We said we're not going to do ECS for excluded.example.com. And then we said for example.org, we're going to do 22 bits that's wrapped quite nastily. Sorry about that. We're going to do 22 bits for v4 and 48 bits for v6. And then example.net is just using the default, which we know is 24 and 56. And here's the bit I said that I would come to later, because I mentioned that ECS forward means that you will accept and use ECS options on the client query that you received as a resolver. But what if the client query scope, so the ECS options and the mask being used on it, is more specific than you want to use per your configuration? In that case, the client ECS options are still used, but we adjust them, that we cap them to the control that we've added ourselves for our own resolver. So the client might ask with 24 bits of subnet, but if you have said in your ECS bits, no, I only want to use 16, we will still use the subnet, but we will truncate it down to being the wider scope subnet within which the client request exists. And we have a typo. In fact, the entire time I was typing this, my tool wanted to use ICS rather than ECS. So in the second bullet point, excuse, but that should be ECS. So if the client query has a smaller prefix, so the client said, oh, I only want to use 16, but you allow up to 24, well, we will use what the client has sent. And then again, I'm re-emphasizing that any client, even one not listed in ECS forward, can use a zero length prefix in ECS options to say, don't do ECS for me, please. This one, it took me a little while to get my head around. This is what it says in the Administrator Reference Manual. If we are allowed to do ECS for this client query, but the client is, and there is no ECS client, there is no ECS option on the client. So if we're doing forwarding and the client, if we're doing forwarding and we would normally do forwarding of client ECS, and we receive a query that has no ECS on it at all, so then it's down to us to do the ECS options. We're not using what the client has sent. What it's saying is, no, we're not going to do ECS. So it took me a while to get my head around this. Why would we say we wanted to do ECS per ECS zones, but then say, no, we don't want to do ECS? I think this is a useful thing where you are the resolver that doesn't normally receive direct client queries, wouldn't normally be expecting to do ECS itself, would normally only be forwarding queries from other resolvers. And you want to honor what they send. So if they send you a query that doesn't have ECS on it, don't add it yourself. You honor what they send. So if they haven't put ECS no scope, so global, they haven't put any ECS at all. And in this instance, they do not want you to add ECS on their behalf. Does that make sense? It's quite a complex thing to get your head around. But I think it is something that a resolver operator in a tiered system of resolvers might want to use, where they want the responsibility for doing ECS to lie solely with the client-facing resolvers and not with the next tier up of resolver. So you don't accidentally, you've got to have ECS zones, otherwise you're not going to be able to do the forwarding, but you don't want that second tier resolver to add ECS where ECS was not provided in the queries that it received. And we have ECS no. And this again is the exception for the servers that misbehave, much like EDNS no, no cookie and similar. I'm going to cover a little bit about how the ECS cache is implemented. If I'm trying to think about it as a mental picture, and apologies I didn't draw a picture here, I like to think of ECS cache as being another dimension to ordinary cache. So you have a regular cache that stores RR sets, many of them. But then when you have got answers that are scoped differently, so they've got ECS options attached to them, and they might be specific subnet that these answers apply to, or they might just be for ECS queries, the scope is global. That means all clients asking for ECS will get the same answer, but it is actually an ECS scoped answer. It just happens to be global. Everyone gets the same one. Imagine those as being stored alongside the other or the original RRs. So you will have one record that is well, you might not even have that actually if nobody asked the question. But suppose you had the scenario where you have one answer which has no ECS on it at all. And then in the same place, sitting behind it in another dimension, you have got the ECS scoped answers that will be used for clients that ask a question that matches an answer that we've got with ECS on it before. So that's how ECS cache is implemented. And inevitably, caches for resolvers using ECS are going to get much bigger. I haven't covered this, or I sort of have covered this. When you query when a resolver queries an authoritative server with a specific ECS scope, ECS subnet, the authoritative server might not answer with the same scope. It might give you an answer with the scope that you asked, or it might not. What is being put in cache is what we got from the authoritative server. So if the authoritative server gave you something with a less specific answer, so a smaller scope, then we're going to put that in the cache, not what we asked for. Because we know that we can use that same less specific scoped answer for more clients. And so we're going to keep that one, because why query again when we're just going to get the same answer? Sometimes you will see that an authoritative server responds with a more specific prefix than the one that we asked for. That's a clue to us that it actually has got more specific answers than we asked for. But we're not going to cache with that. We're going to cache with what we asked for. Now, here's the rub. Negative answers are always cached with global scope. Negative answers are things like NXRR set, the name that you asked for does not exist. They might also be, sorry, NX domain is the answer, the question you asked, the name that you asked for does not exist at all. NXRR set is the name that you asked for exists, but not the type of the thing that you queried. These are all cached at global scope. You cannot have this doesn't exist by specific scope. You can only have that by global scope. The same thing applies to delegation responses, by the way. This is covered in the RFC in a bit more detail with a lot of background on the discussions on why, but basically it's because it will have a tendency to break things that otherwise work in the DNS. So that is why negative answers are global scope. This does have some significance for CDN providers, as we'll see later. We've got some useful bits and bobs for troubleshooting and investigating and finding out what you've got. So if you're using the S edition, then you have a new option to the rndc dumpdb command that will allow you to see the ECS scoped RR sets when you dump the cache, if you wanted to see what you've got. Anybody using dumpdb and then using S edition and using ECS, you'll need to know this. If you're using a dig that has been built from the S edition, then you have a new option, which is plus subnet equals. By the way, dig that isn't built from the ECS doesn't appear to have this, because I shot myself in the foot trying that with 9.18 standard. No, it's not there. So you have to be using a dig that comes with the S edition to have the plus subnet equals. If you go back to the earlier slides very early on, you'll see that I used that. So using that, if you wanted to test an authoritative server's responses, you would send your dig command to the authoritative server that you wanted to query. You would use plus no rec, and that you would do to turn off recursion desired, because you're querying an authoritative server and you're pretending to be a resolver. So you will turn off recursion, and then you would add the subnet that are the scope that you want to query for. So that's your ECS options. Funnily enough, and this is useful outside of ECS, you can send the same sort of query to a resolver if you want to find out what it's got in cache without it doing any more queries on your behalf. And for that, you disable recursion. So you do plus no rec, and then you can find out what's in cache without the server going off to do other things on your behalf. So gotchas. I keep mentioning cache bloat. Yes, your cache is going to get bigger if you're using ECS. You're going to need to take that into account based on the scope that you're using, the ECS bits, where your clients are, because if your clients are predominantly in the same geography and the same subnets, probably isn't going to bloat that much. You need to think about DNSSEC validation. Are you doing it? Does it matter to you? Does it work with the authoritative servers that you're querying that are responding with ECS scoped responses? Think about the option that I told you about for stopping the server from throwing away surprise query responses that have ECS on them when you never even asked for it, because that's a difference between a server that is ECS aware and a server that isn't. Bear in mind that as soon as you have enabled ECS on your resolver, if you don't have ECS forward, then it is going to turn away the clients that have actually put their own ECS options on their queries, apart from the ones that have said, don't do ECS on my behalf. So you may find that if you've got clients that you didn't expect to be adding ECS options when they queried you, you're going to be refusing them instead of processing their client queries, simply because you've turned on ECS. And emphasizing again, negative server responses are globally cached. You cannot cache and deal with this doesn't exist, but only for the subnet. That is not going to work, because as soon as you've got a negative response for one subnet, then all of your positive responses for the other subnet scopes are gone. That name no longer exists, or that name and record no longer exists. Which leads me to transient CNAMEs, and this we have seen. So some CDN content distribution networks will use CNAMEs when they want to provision. Maybe it's got a little bit busy and they want to offload some of the traffic somewhere else. So some of the time they'll be responding with an A record. And at other times, they'll be responding with a CNAME for some of the scopes. So where this can go slightly awry is if somebody queries via your resolver for the CNAME, or the resolver queries itself for the CNAME. Maybe it's doing prefetch for something that's about to expire from cache. And yes, prefetch does apply to ECS. And where it falls apart is if the authoritative servers have no idea what to do with a CNAME response, a CNAME query, and respond with, well, I don't know, it doesn't exist. Suddenly, you have got a negative response to a CNAME query, and that's going to be cached globally. So suddenly, you lost all of your CNAMEs that you had cached before. It's probably not that big a deal, but you need to be aware of it, because if the CNAMEs are gone, fine. But the CNAME was there before for that scope and there was no A, so the clients are just going to have a cache miss and query again, and so the resolver is just going to query the auth servers again. But be aware that this is an interesting pitfall or an interesting gotcha with your caching with CNAMEs. I have not seen this personally, but I have heard. So some authoritative servers just don't do the right thing when they get ECS options. So that's a pitfall and things that you need to be aware of. I have heard, or I have seen in another presentation from somebody talking about the pitfalls of ECS, that there are some authoritative servers that when asked for an ECS scoped query, don't actually have ECS themselves. They always send the same answer back. But they'll always send back an answer with the ECS subnet as requested with the matching prefix. So they're sending back the same answer, but they're telling you wrongly that it is scoped to the ECS that you request, the ECS subnet that you requested. I mean, that's just That's just antisocial behavior as far as I'm concerned. But yes, this is the thing that has been seen. I've mentioned the surprise unsolicited ECS options and how to get around those. And the other thing that we have heard, and I expect that you already know, is that GeoIP databases are not always correct. So if you're using specific subnets and expecting them to match your clients, sometimes they're not right, and you will have to go through the process of getting them corrected, whichever GeoIP database it happens to be. And the other thing I've heard along the way, which I was surprised at, so right at the very, very beginning, I said that the resolver would send the query from itself with no ECS options on it without EDNS. So the authoritative server sees the query as coming from the resolver, and the only data it has to go on is the IP address of the resolver if there's no ECS. If there is ECS, then it can use the ECS options. So authoritative server has two sources of where is the client. One is the resolver IP address if there is no ECS. The other is ECS options if there is ECS. Some authoritative implementations use different GeoIP databases for the same for this business. I don't know why. I'm sorry, but that is also something to be aware of. So I think that I have covered why you might use ECS, how you might use it effectively, what the options are, a little bit about how the ECS catch is implemented, and a little bit of detail on things that can catch you unawares and how to get around some of them. You have a lot of options, a lot of configuration things that you can do at your disposal. And you also have some troubleshooting tools, dig and dumping the ECS cache. And that's that. Any questions?
Well, we do have, thank you very much for that, Kathy. That was excellent. And I think it has definitely helped to explain why this isn't part of the open source implementation because of the number of ways you can shoot your foot off. We do have a question from Greg. Can ECS forward accept named ACLs?
You know, I don't know the answer to that question. I have not seen anybody do it, and I have not tried to do it myself. I would have thought in theory, yes, but I think you're going to have to try it and see.
In that case, I shall try it and see.
Thank you. Okay, we don't have any other questions that I can see. This is sort of a stupid question, but I have to ask. In a number of places you mentioned that the client can indicate that they basically don't want ECS applied to them, that they basically want to preserve their privacy. And it strikes me that if this is a thing that one can manipulate, it might be a good way to get around the country-specific blocking on, say, watching your favorite Netflix while you're in the wrong country. Do you have any comment about that, or is...
I suspect that that kind of implementation is a little bit more clever than that. What we're doing here is just the DNS side of things anyway. And when you are watching Netflix or whatever, DNS is only the first step, and then you have to attach to the Netflix stream. So, yeah, I suspect it's not going to help. It might get you round some other blocks depending on whose server you query. Difficult. Don't know.
Okay.
Have to think it through in specifics.
Okay, we do have one more question. This is a good question from Darren. Any advice how specific the ECS bits should be? And I think, as you know, there's some BCP around this.
So you're playing the balance game here. You want to get answers that are appropriate to your clients. If you know your clients and know that fundamentally they're all in the same geography, then you can probably be fairly non-specific. But if you want to get more specific answers, also, if you've done an internal implementation, do you remember the example I gave where we had overridden the maximum limit on the prefix and we'd set it to explicitly give the client address the whole of it in all of the queries? So you might do that if your ECS zones were set up just to do ECS for some internal service that wanted, for example, to monitor the client queries for that name and give a client-specific answer. Maybe it's a permissions thing. I don't know. So it all depends on your use case. I can see another question actually from Greg.
Right, go ahead.
So you can set ECS bits to be larger than 24, but you have to have built bind so that the maximum limit has been changed to be larger. So it's a build thing. It's built in, but the build can override the built-in. Does that make sense?
I think so. It's just one of your slides. It was around about 30 or 31, I think. Showed some example where you were sending the entire client address, i.e. /32 for an IPv4 client.
Yes. So if I skip back through this, I'm not going to skip back through my slides. No, it won't go. No. Yes, it will. If I skip back through my slides, you have got some compiler flags and build options. That's the third bullet there, where you can define a value for max v4 scope and another value for max v6 scope, which are bigger than 24 and 56. And when you build bind with those, then the max allowed, so the max that you can configure, is bigger. That's how you succeed in doing that.
On the next slide.
So on my next slide,
The
yep.
bottom example.
So in that example, I have set ECS bits to be bigger than a max allowed. My assumption here is that when I built bind, I built it with those options on the previous slide, so that
Right.
the max was moved.
Okay, so that bottom example only applies if you have built bind yourself and deliberately changed the defaults.
Yes. Yes.
Thank you.
It doesn't change the defaults. Sorry. You said defaults.
No.
The defaults and max.
The ceiling.
Yes, the ceiling. The defaults and the ceiling are two separate things. The default doesn't change if you use those compiler flags in the third bullet. I'm not even going to attempt to pronounce them. So the default doesn't change, but the ceiling, the maximum, does. And it's the ceiling, and in fact, it's the values of ECS max v4 scope and ECS max v6 scope. I did say I wouldn't say them, didn't I? It is the value of those within the code that is being used to compare with the configuration of ECS bits to say whether it's allowed to accept that configuration or not.
Understood. Thank you.
So Kathy, we have another question about limits. Someone has observed that the ECS cache could certainly be turned into a resource depletion attack. And so the question is there a cap on the ECS cache? Should we consider adding one?
You could do resource depletion on any resolver, not just one using ECS. So there's an element of how much do you trust your clients?
Yeah, I think the point is, as you pointed out, ECS itself naturally is going to bloat the cache. I mean, that's how it works. So it does seem as if you are planning to enable ECS, you should plan for some additional overhead.
You're going to have to plan for an overhead for your ECS cache. I don't think. I mean, there already are cache cleaning things and limits on cache size anyway that will cause cache to be cleaned when it reaches the limit. So this is just a way of getting to the limit faster, I guess. But then if you knew that you were going to get to the limit faster, then you would set a much, much bigger limit so that you didn't hit it so soon. I don't think if you're running a resolver, you are to some extent at the mercy of your clients and what they can query for. So you have to take that into account when you're provisioning. There's information about the website and where to get our software from, where we store our engineering requests, which I think most people know. And I was guessing that it was Czech Republic, Czechia, and Namibia that people wouldn't know offhand unless they happen to have been to either of those.